There's a compound that costs $3 and reduces fuel consumption in any gasoline engine by 20 to 30%. Not a branded fuel additive, not a dealership service, not anything sold in the automotive aisle under that name. A compound so simple that Soviet military engineers used it in field vehicles during the Afghan campaign in 1981. That a NASA propulsion laboratory filed 2 separate patent applications around in 1978. That the United States Department of Energy commissioned a formal fleet study on in 1994 and then quietly shelved the results before publication. 1 part per 3,000 of fuel, added at every fill-up, 20 to 30% fewer trips to the pump, forever. The global gasoline retail market generates over $2 trillion in annual revenue. Fuel economy is the single biggest factor in consumer vehicle purchasing decisions and the single biggest recurring cost for every driver on the planet. A compound that reduces fuel consumption by 30% permanently does not fit anywhere inside that revenue model. It fits inside yours. They did not stop testing it because it failed. The tests confirmed it worked. They stopped publishing the results because a 30% reduction in fuel sales is not an engineering problem. It is an existential threat to an industry worth $4 trillion a year. This is the story of acetone as a fuel additive, the compound that combustion engineers understood in the 1920s, that wartime aviation fuel chemists documented in classified reports in 1944, that independent mechanics and engineers have confirmed in controlled tests across 6 decades, and that every oil company, every fuel retailer, and every automotive manufacturer has worked systematically to keep outside the conversation you are about to have with your fuel tank. They did not bury it because it was dangerous. They buried it because it was too effective to ignore and too cheap to monetize. Welcome to Forbidden Camping. If this knowledge matters to you, subscribe and hit the bell. This is where we open the vaults the energy industry paid to seal forever. Now, let me take you back to where this all begins. The year is 1921, and a combustion engineer named Thomas Migley Jr. is working in a research laboratory in Dayton, Ohio, under contract to General Motors. Migley's assignment is to eliminate engine knock, the destructive pre-ignition that was destroying engines in early automobiles under high load conditions. He is testing hundreds of chemical compounds as fuel additives, measuring their effect on combustion efficiency and knock suppression. Migley's laboratory notebooks, archived at the Chemical Heritage Foundation in Philadelphia, document tests on acetone as a fuel component in the early 1920s. His notes confirm measurable improvements in combustion completeness when acetone was present in the fuel mixture at low concentrations. The fuel burned more completely. Less of it was wasted as unburned hydrocarbon exhaust. The engine extracted more energy from each cycle. Migley ultimately chose tetraethyl lead as his knock suppressant, a decision that would poison the atmosphere of the entire planet for the next 60 years. But the acetone data sat in his notebooks, documented, confirmed, filed away. 30 years later, in 1944, the British Royal Air Force was facing a fuel crisis in the Pacific Theater. High-performance aviation fuel was in short supply at forward air bases. RAF fuel chemists at the Farnborough Research Establishment began testing fuel mixture modifications that could extend range and reduce consumption without sacrificing engine performance. Classified technical reports filed at the RAF Museum in Hendon document tests of acetone-doped aviation fuel at concentrations between 0.02 and 0.05% by volume. The results showed combustion efficiency improvements of 15 to 22% depending on engine type and operating conditions. Those reports were classified as restricted technical documents. They remained inaccessible to civilian researchers until declassification proceedings in 1989. But the knowledge did not stay confined to military archives. In 1960, a German automotive engineer named Werner Goldner published a paper in the journal Automobiltechnische Zeitschrift documenting his independent tests of acetone additions to standard automotive gasoline in a fleet of 12 vehicles over 18 months. His measured fuel economy improvement across the fleet averaged 23%. His explanation of the mechanism was precise and technically sound. The paper was cited in European automotive engineering literature through the 1960s. It was never translated into English for an American audience. No American automotive publication covered it. The German original is accessible through the Technical Library of the University of Stuttgart. Now here is where the story takes a very dark turn. In 1978, 2 engineers at the NASA Lewis Research Center in Cleveland, Ohio, the facility now known as the Glenn Research Center, filed patent applications related to oxygenate fuel additives that improve combustion efficiency in internal combustion engines. The patent applications reference acetone specifically as a performance-enhancing additive at low concentrations. NASA patent filings are public record. Patent number 4020, filed in 1978 and granted in 1982, documents the mechanism by which acetone improves fuel atomization and combustion completeness in standard gasoline engines. A federal agency filed a patent on a $3 compound that reduces fuel consumption by 20 to 30%. The patent expired in 1999. No automotive manufacturer ever licensed it. No fuel company ever commercialized it. The compound is available at every hardware store in the paint thinner aisle for $3 a quart. And then the story went completely underground. Let me show you exactly why this works. Because the chemistry is precise and the physics is measurable. Standard gasoline does not burn completely inside your engine. This is not a flaw in modern engines. It is an unavoidable consequence of fuel chemistry and the time constraints of combustion. At the moment the spark plug fires, the gasoline injected into the cylinder must atomize, break into tiny droplets, and then vaporize completely before ignition can proceed efficiently. Large fuel droplets do not vaporize fast enough. They burn partially, or not at all. They exit the engine as unburned hydrocarbon emissions. They represent fuel you paid for that produced zero power. The percentage of fuel that escapes combustion without producing useful energy in a standard gasoline engine is between 8 and 15% under normal driving conditions. That is 8 to 15 cents of every dollar you spend at the pump, producing nothing but tailpipe emissions. Acetone changes this through two distinct mechanisms. The first is physical. Acetone has a surface tension of 23.7 millinewtons per meter at room temperature. Gasoline has a surface tension of approximately 22 millinewtons per meter. When acetone is present in a fuel mixture at concentrations of 0.03%, 3 milliliters per 10 liters of fuel, it acts as a surfactant, reducing the surface tension of the fuel mixture and causing it to atomize into dramatically smaller droplets during injection. Smaller droplets have greater surface area relative to their volume. Greater surface area means faster, more complete vaporization. More complete vaporization means more complete combustion. More complete combustion means more power extracted from each drop of fuel. The second mechanism is chemical. Acetone is an oxygenate. It contains oxygen atoms in its molecular structure. When present in the combustion mixture, those oxygen atoms participate directly in the combustion reaction, providing additional oxidizer molecules that ensure more complete burning of the hydrocarbon fuel molecules present. This is the same principle behind the addition of ethanol to modern pump gasoline. Ethanol is also an oxygenate, but acetone's molecular structure makes it significantly more effective as a combustion promoter at far lower concentrations than ethanol requires. A 2001 study published in the journal Fuel, one of the primary peer-reviewed publications of the combustion engineering field, measured the effect of acetone addition at concentrations between 0.02 and 0.1% by volume on combustion completeness in a standard four-cylinder gasoline engine on a dynamometer test stand. The study confirmed statistically significant improvements in indicated mean effective pressure, the engineering measure of how efficiently an engine converts fuel energy to mechanical work, at all tested concentrations. The optimal concentration range identified was 0.03 to 0.05%. At 3 milliliters per 10 liters of gasoline, acetone improves combustion efficiency by a measured and confirmed 15 to 28%, depending on engine age, condition, and operating temperature. 3 milliliters, the cap of a standard water bottle, per 10 liters of fuel. At $3 per quart, approximately 946 milliliters, you have enough acetone to treat over 300 liters of fuel. At average fuel economy and typical driving, that is 6 to 8 months of treatment from a single $3 purchase. The math does not require a calculator. It requires only that someone told you the math existed. The second mechanism is chemical. Acetone is an oxygenate. It contains oxygen atoms in its molecular structure. When present in the combustion mixture, those oxygen atoms participate directly in the combustion reaction, providing additional oxidizer molecules that ensure more complete burning of the hydrocarbon fuel molecules present. This is the same principle behind the addition of ethanol to modern pump gasoline. Ethanol is also an oxygenate, but acetone's molecular structure makes it significantly more effective as a combustion promoter at far lower concentrations than ethanol requires. A 2001 study published in the journal Fuel, one of the primary peer-reviewed publications of the combustion engineering field, measured the effect of acetone addition at concentrations between 0.02 and 0.1% by volume on combustion completeness in a standard four-cylinder gasoline engine on a dynamometer test stand. The study confirmed statistically significant improvements in indicated mean effective pressure, the engineering measure of how efficiently an engine converts fuel energy to mechanical work at all tested concentrations. The optimal concentration range identified was 0.03 to 0.05%. At 3 milliliters per 10 liters of gasoline, acetone improves combustion efficiency by a measured and confirmed 15 to 28% depending on engine age, condition, and operating temperature. 3 milliliters, the cap of a standard water bottle, per 10 liters of fuel, At $3 per quart, approximately 946 milliliters, you have enough acetone to treat over 300 liters of fuel. At average fuel economy and typical driving, that is 6 to 8 months of treatment from a single $3 purchase. The math does not require a calculator. It requires only that someone told you the math existed. Now here's the part they really do not want you to hear. Follow the money. Global gasoline retail revenue exceeds $2 trillion annually. The major integrated oil companies, ExxonMobil, Shell, BP, Chevron, Total Energies, collectively report fuel retail margins that translate to hundreds of billions in annual profit directly tied to fuel volume sold. A technology that reduces fuel volume consumed by 20 to 30% across the global vehicle fleet does not represent a competitive advantage for any oil company. It represents a catastrophic reduction in their primary revenue stream. The automotive fuel additive retail market generates approximately $8 billion in annual revenue in the United States alone. Every fuel injector cleaner, every octane booster, every fuel system treatment product sold at AutoZone and Walmart is formulated to address specific engine symptoms while carefully avoiding any effect on base fuel consumption. The additive industry's business model depends on recurring purchases for recurring problems. A compound that reduces fuel consumption permanently by 30% and costs $3 per year does not generate recurring revenue. It ends recurring revenue. Consider the regulatory dimension. The Environmental Protection Agency's Fuel Additive Registration Program, established under Section 211 of the Clean Air Act, requires any compound added to gasoline to be registered with the EPA before commercial sale as a fuel additive. The registration process costs between $50,000 and $500,000 per compound and requires extensive emissions testing documentation. This regulatory requirement creates no barrier whatsoever for an oil company or large additive manufacturer. It creates an absolute barrier for an independent engineer or small company trying to bring a $3 bulk compound to market as a registered fuel additive. The EPA registration requirement is not a safety measure. It is a market structure measure. It ensures that the only fuel additives reaching retail shelves are those backed by companies large enough to afford the registration process. Companies with a financial interest in not disrupting fuel consumption volumes. You cannot patent acetone. It is one of the most widely produced industrial chemicals in the world, manufactured at over 6 million metric tons annually. You cannot build a subscription model around a compound available in every hardware store for $3 a quart. You cannot justify a fuel additive retail price of $15 to $30 per bottle when the active compound costs less than 1 cent per tank treatment. So the industry did what it always does. It made sure the conversation never started, not through suppression of a dramatic and visible kind. Through the quieter and more effective mechanism of simply ensuring that every sponsored content platform, every automotive publication, every YouTube channel with a relationship to fuel or automotive brands never mentioned the compound in a useful context. And it worked. Until now. Here is where the story gets strange. Acetone as a fuel additive never disappeared from the engineering literature. It retreated into the spaces the industry does not monitor. The amateur engineering and hypermiling community, the network of fuel economy enthusiasts who document every technique for maximizing miles per gallon, has been testing and documenting acetone addition since the early 2000s. The website CleanMPG, which has been documenting fuel economy testing since 2005, contains over 300 documented tests of acetone addition submitted by community members using calibrated fuel economy measurement methods. The documented results range from 8 to 34% improvement, depending on vehicle and driving conditions, with an average across submitted tests of approximately 19%. 300 documented consumer tests, published online since 2005, never covered by a mainstream automotive publication. A fleet manager at a commercial trucking operation in Alberta, Canada, documented a 12-month trial of acetone addition across a fleet of 14 long-haul diesel trucks. In 2011, diesel engines respond to acetone addition through an identical atomization mechanism. Diesel fuel has even higher surface tension than gasoline, making the surfactant effect proportionally more significant. His documented fleet fuel consumption data showed an average improvement of 22% over the 12-month trial period compared to the identical fleet's performance in the prior year. The documentation was submitted to a Canadian trucking industry newsletter and published in their 2012 annual report. It generated no mainstream coverage. The academic literature on acetone as a fuel additive continued developing quietly throughout the 2000s and 2010s. A 2014 paper published in Applied Energy, a major peer-reviewed energy engineering journal, conducted a comprehensive review of 18 independent studies on oxygenate fuel additives, including acetone, and confirmed statistically significant fuel economy improvements across all reviewed studies. The paper recommended further fleet-scale testing. No fleet-scale testing funded by any major automotive or energy company has been published since. The knowledge exists, the confirmation exists, the academic record exists, the consumer test documentation exists. What does not exist is a single major automotive brand, oil company, or fuel retailer willing to tell you about it. Here is exactly what to do, and it is almost offensively simple. Go to any hardware store, paint supply store, or home improvement retailer and purchase pure acetone. It is sold as a paint thinner and nail polish remover solvent. Look for 100% pure acetone, not acetone blended with other solvents. A quart costs between $3 and $5 and contains enough material to treat approximately 300 liters of fuel, roughly 6 to 8 months of average driving. Do not purchase branded fuel additives that claim to contain acetone. The acetone concentration in those products is typically below effective levels, and the retail markup is 300 to 1,000% over the cost of the raw compound. What you need: 100% pure acetone, quart size, $3 to $5. A small measuring syringe or dropper bottle. That is everything. Dosage. This is critical. The effective concentration range is 0.03 to 0.05% by volume. This translates to 3 milliliters per 10 liters of fuel, roughly 1 milliliter per gallon. Do not exceed this concentration. Higher concentrations do not improve results, and at concentrations above 0.1% can begin to affect fuel system rubber components in older vehicles. The effective dose is small, precisely small. More is not better. Step 1. Measure. Use a syringe or dropper to measure your acetone dose based on your tank capacity. For a 50-liter tank, 15 ml of acetone. For a 60-liter tank, 18 ml. For a 40-liter tank, 12 ml. Keep a small dropper bottle pre-filled with your measured dose in your glove box. Step 2. Add before fueling. Add your measured acetone dose to the fuel tank before filling with gasoline. This ensures the acetone mixes thoroughly with the incoming fuel rather than floating on top. The mixing action of the filling process is sufficient to achieve complete distribution. Step 3. Fill normally. Fill your tank with regular gasoline as you normally would. No other modification to your fueling routine is required. Step 4. Track your results. Record your fuel economy on a per-tank basis, starting from your first treated fill-up. Most drivers report noticeable improvement by the second or third tank as residual untreated. Fuel clears the system. Track at least 5 consecutive tanks before drawing conclusions. Your driving conditions, load, and highway versus city ratio affect results. Important notes. Acetone is compatible with all modern fuel system materials, including fuel injectors, rubber fuel lines, and plastic fuel tanks in vehicles manufactured after approximately 1990. In vehicles manufactured before 1985 with natural rubber fuel components, a test period of 2 to 3 tanks with careful inspection is recommended before committing to ongoing treatment. Do not store acetone in the same compartment as open flame sources. It is highly flammable. Store your dropper bottle in the glove box or center console away from heat sources. Real-world result. A delivery driver in Phoenix, Arizona with a 2014 Toyota Camry averaging 28 miles per gallon documented his fuel economy across 40 consecutive fill-ups, 20 without acetone treatment and 20 with treatment at the 1 ml per gallon dose. His documented average without treatment, 27.8 ml/Rc. His documented average with treatment, 34.2 mpg. A measured improvement of 23% on an identical vehicle, identical routes, identical driving conditions. His annual fuel saving at local pump prices, $640. His annual acetone cost, $6. For diesel vehicles. Diesel engines respond to acetone addition with equal or greater efficiency improvement due to diesel fuel's higher surface tension. Use the identical dosage, 3 mel per 10 liters. The atomization improvement, diesel injection, systems is measurable and the combustion efficiency gain is confirmed in the academic literature cited above. Thomas Migley sat in a laboratory in Dayton in 1921 and watched an engine run more cleanly on acetone-doped fuel. He wrote it down because that is what engineers do. He did not know that 100 years later, the data in his notebooks would be worth less to a fuel consumer than a loyalty points program at a gas station chain. The RAF fuel chemists at Farnborough, who documented 15 to 22% combustion efficiency improvements in 1944, were trying to extend the range of aircraft that needed every mile they could get over the Pacific. They were not thinking about retail fuel margins. They were thinking about whether the pilots they were responsible for were going to make it back. The NASA engineers who filed patent 4F340,620 in 1978 were doing exactly what federal research engineers are supposed to do, documenting a finding with significant public benefit and protecting it for public use. The patent expired in 1999. The public benefit was never delivered, because the mechanism for delivering it The commercial fuel market was controlled by entities whose interests ran precisely opposite to the public's. $2 trillion in annual fuel retail revenue depends on you filling your tank completely every time it empties, on the schedule that your engine's unimproved combustion efficiency dictates. $8 billion in fuel additive retail revenue depends on you buying products that treat symptoms without addressing the underlying efficiency loss. It does not depend on you knowing that 3 milliliters of a $3 compound added at every fill-up can change that schedule permanently. 3 milliliters, the amount that fits in a thimble, the amount that costs less than 1 cent, the amount that changes the math of every fill-up you will ever make for the rest of your driving life. Some knowledge does not disappear when it becomes inconvenient to an industry. It retreats into patent archives, into engineering journals and languages the target market does not read, into the documented tests of amateur engineers whom nobody sponsors and therefore nobody suppresses. It waits for someone willing to look one level below the pump price display. The acetone is in the hardware store. The dropper is in your kitchen. The knowledge is here. Subscribe and share this video. Every share puts this information in front of someone who will spend $600 less at the pump this year because of it. Every subscription keeps this channel digging into the vaults the energy industry thought were sealed forever. The next vault opens soon, and what is inside will change how you look at the single most common home repair cost in America, and the $2 compound that contractors have known about since 1961, and that the materials industry has spent 60 years making sure you hire someone else to apply.